We're having a look at our lawn and fertiliser question again. So we still know there's 100 metres squared of lawn, has 3 litres of fertiliser. How much for 750 square metres? Now we're looking at how do we approach this using algebra. Even though we've used unitary methods, sometimes the numbers aren't so nice, and algebra can be a real friend to you then. So you have to think about what's depending on what. We know there are 2 quantities. We know that. There's area of your lawn, and there's the litres of fertiliser. What we need to work out is which of our variables. We would say both of these vary, they can both change, and one varies depending on what the other does. So we would say that x is our independent variable, which means it's just going to vary as it pleases, and y is our dependent variable, which means what happens to y is going to depend on what happens to x. In this situation, the way the question is written, the amount of fertiliser you have is going to depend on how much lawn you've got. So the lawn is simply what it's going to be. The area of the lawn is our independent variable. You've got some lawn, nothing's creating that. The amount of fertiliser you need is going to depend on how much lawn you've got. So our y variable, our dependent variable, is the amount of fertiliser. Now you must be very clear which is which before you go setting up anything, or you'll get very confused. So be very clear about which is the independent and which is the dependent variable, because we always use the same equation. Y equals, just change my colour, K X. This is the standard equation that you can set up whenever you've spotted a direct proportion situation. And if you watch the video on the unitary method, I'll talk about how we know this is direct proportion. So your first job before you can solve for x or y is to get a value for that k for this particular situation. So just like unitary method, we've got a ratio we already know. We know that when the lawn is 100 metres squared, the fertiliser is 3 litres. So we have to solve for k by using known values of x and y. Now remember that x is the area of the lawn, and the lawn is 100 metres squared. We know that. Y is the amount of fertiliser that you need, and we know for 100 we'll need 3 litres of fertiliser. So I put in my known values of x and y for a particular ratio, and that allows me to solve for k. Find out what is this k. It's called a proportional constant for this particular situation. To solve for k, I'm going to need to undo that multiplied by 100. So I'm going to divide both sides by 100. And if I tidy up my work, I can cancel on the right hand side as I expected. I have k equaling 3 over 100. If you want to try and write that as a decimal 300ths, that's what you would get, but you don't need to. Either one is fine. Okay, now that we know what k is, just move my page up a little bit. So now I can write the standard equation for this situation because I know my k value. So for anything to do with our lawn and fertiliser, we know that y equals 3 over 100 by x. For any situation with this lawn and fertiliser. So just like unitary method, we began with a ratio that we did know about, and then we moved to sort of half the information. We want to know, I want to know the litres of fertiliser, and the litres of fertiliser is my dependent variable. I want to know the litres of fertiliser for 750 square metres of lawn. So I can substitute what I can into my standard equation. Y equals 3 over 100x. Now I actually know what x is for the situation I'm interested in. Y still equals 3 over 100 by 750. I'm going to do a bit of cancelling here. I can divide the numerator and denominator because that's just like a fraction. And then tidy up and let's see what I've got. I've got 3 by 75. Do a little algorithm over here if you need to. 3 5s are 15, 3 7s are 21, and 1 is 22. You can do that kind of thing. So I've got 225 over 10. Let me just move that up for you. You can do a division if you need to. 225 divided by 10. Or you can remember the connection between fractions and decimals. This number here is worth 225 tenths. 225, and if I put my decimal there, it's 225 tenths. So my answer is 22.5 litres. Just move that up. So this is my final answer, and if you have a look at the unitary method, you'll see that it also produces the same result.